simultaneous equation. Now, I'm going to be talking about simultaneous equation. Now, when we talk about simultaneous equation is talking about equations that is more than one. That is, you of course, from the word simultaneous means it's occurring at the same time. So we're looking at two or more equations in which you have two or more variables, and they have to attain a particular value at the same time. I'll also use some examples. Now, the first one I'm going to talk about is simultaneous linear equations, and there are two major methods for solving that. First is the elimination method, which is also called equating coefficients, while the second is substitution method. Now, right here I'll be emphasizing on the elimination method because after using the elimination method, I'll still employ the substitution method. So invariably, I'll be talking about the two, but I will be sticking out for the elimination method. Um, then the examples we have, if we are told to solve this equation, this simultaneous equation, that is, we're having two linear equations. This is one linear equation, this is another linear equation. Now, solving it means the value of x that will be true for this equation and that will also be true for this equation. Also, the value of y that will be true for this equation and be true for this equation. I may use any value of y, but the value of y may be true for this equation, it may not be true for this equation. The same thing happens for x. The value of x may be true for this equation, may not be true for this equation. But I need the value of x and y that will be true for both equations at the same time. That is where the word simultaneous comes in. The value of x and y that will be true for this equation and for this other equation. So what do? We check out the solution. What we usually do is we call the first linear equation equation 1, then the second linear equation we'll call it equation 2. Now I'll be using the elimination method here. Now, when we talk of elimination method means we want to eliminate, and once we talk about elimination, we want to eliminate, it means we want to cut out something, we want to take that right off. So the first thing that comes in if you are treating elimination method is this: make sure that the variable are under their self. That is, x is under x and y is under y. Once you make sure that they are in a line vertically, that is in column wise, they are in aligned under their self, then the next thing you're gonna ask yourself is this: which one do I want to eliminate? Do I want to eliminate x or do I want to eliminate y? Now I know most of us love to eliminate what? X. So if you now ask yourself, I want to eliminate x. Okay, if I want to eliminate x, then the next question you now ask yourself, since you decide to eliminate x, the coefficient of x, are they the same? If they are not the same, then you have to do something so that they will be the same. If they are the same, you will just eliminate it straight right off. But in this case, if you look at this x, the coefficients are not the same. So what do? How do we try to make it the same? We try to make it the same by multiplying the equation 1 by this coefficient down here and multiplying the equation 2 by this coefficient right here. By doing that, you will make them the same. If you use this coefficient of x here, which is 3, to multiply the equation 1, you have this right here. And if you use this coefficient of x here, which is 2, to multiply equation 2, you will have this right here. Remember, I decided to do it this way: multiplication and opening up the bracket, to show that these 3 will multiply each of these 10, and also to show that these 2 will multiply each of these 10. So please, whenever you are using a number to multiply an equation, it multiplies all the terms throughout. So therefore 3 times 2 is going to be 6x, 3 times 5 is 15, and 3 times 1 is 3. That's for equation 1. And for equation 2, 2 times 3 is going to be 6x, and 2 times minus 2y, that's going to be minus 4y, and 2 times 30 is going to be 60. So what have you done here? You've now made the coefficient of x the same. Now, since the coefficient of x is now the same, The next question you're going to ask yourself is this: how do I eliminate it? Now, you eliminate it, that is, by making the value 0. What you usually do is to add the equation 1 to the equation 2. Now, if you ask yourself, if I add equation 1 to equation 2, will I be able to eliminate this x? Because if you say that, oh, 6x plus 6x, that is 12x, in that case it has not been eliminated. So what do I do so that it will be eliminated? What I do is to what? Subtract. Because when I subtract, when I say that 6x minus 6x, that's going to be 0. I've now what? Eliminated. So what you do next is to what? Draw a line under. Then, because you know that, oh, I don't need to add, I need to what? Subtract. What do? You introduce a negative sign. And remember, that negative sign you introduce, we multiply each of the terms. Please be very careful. Anytime you're multiplying an equation by anything, that thing multiplies each of the term. It goes for each of the term. Please, it's just like what we've been doing earlier on, where we multiply each term of the fraction by the LCM. It affects each of the terms throughout. So what do? We introduce this negative sign. Then that means 6x minus 6x, that is going to be 0. So it means what we've done here is that we've eliminated 6x. The next thing is to use this negative to multiply this other term here. So minus times minus 4y, that is going to be plus 4y. Now in your mind right now, you now know that the actual value you're having here is plus 4y. So you ask yourself, 15y plus 4y, of course that's going to be 19y, which you're going to be having here, 19y. And you also know that this negative is going to multiply this 60 right there, so that is going to be minus 60. It used to be plus 60, it now becomes minus 60 because this negative right there multiplies it. So you now have 3 minus 60. 3 minus 60, that's going to be minus 57. So you are now down to 19y equal to minus 57. So what do? Make y the subject formula by dividing both sides by 19. Then y is going to be equal to minus 57 divided by 19, and that's going to be minus 3. So by doing this now, you've been able to get the value of y by eliminating x. You could have decided to eliminate y. Once you eliminate y, then you get the value of x. Anyhow you do it. The most important thing is for you to know that, oh, if you decide to eliminate a particular variable, make the constant the same, then introduce whatever sign you have to introduce, whether it is plus or minus, in order to eliminate that. Now the next thing we'll now do is we substitute this minus 3 for y in equation 1. You could decide to substitute it into any of the equations, but you see that equation 1 gives you a lesser value to work with, unlike equation 2. So it is always better to substitute into equation 1. You can even decide to use any of these equations which you've modified, but these are larger values. So use the I'll prefer if you use the equation that deals with lesser value, because now y is minus 3. So anywhere you see y, you're going to insert minus 3. Now this is the idea of substitution. Now you're now substituting. So this is equation 1. So anywhere I see y, what will I put? Minus 3, because this 5y means 5 times y. So I will have 5 times minus 3. And if you work that further, you're having 2x. 5 times minus 3 is going to be minus 16 equals to 1. So what do? You have this 2x. If you take this to the other side, it becomes y plus 16. Then you're having 2x equal to 16. So what do? You divide both sides by 2, and x is going to be equal to 16 over 2, which is going to be 8. As simple as that. Now you've gotten the value of x, and you've gotten the value of y. So you say that x is equal to 8 and y is equal to minus 3. Now most times, because I've checked through some questions, they like to leave the answers in coordinate form. And remember, for coordinate form, the general convention is that x should come in first and y should come in second. It's always x comma y. So therefore, you want to put the value of your x first and the value of your y as coming the other way around. Sometimes your final answer could be given in this form when you're working with some OBJ question. So take good note of that. X comes first and y comes minus 2. Sometimes you'll be trying to be confused by having minus 3 comma 8. No, that would be wrong because this is the general summation. So it should be this in this form, in this answer. Now, if you are to solve this other question right here, we have to solve this one. Now, this is simultaneous equation involving fraction. It's very simple. The first thing you have to do is to try and convert this fraction to a linear this equation involving fraction to a linear equation, and we all know how to do that. So if I take the first one, which is this, I have this. I know that this is still the same thing as this because 1 times x is x over 2, 1 times y is y over 3, and 4 is the same thing as 4 over 1. What will I do? The LCM is what? 6. I multiply all 3 by 6. We all know how to work with this. So 2 in here is going to be 1, 2 in here is going to be 3. So I'm having 3x times 2y right here. Then I'll be having 24 right here. So this is still my equation 1. If you decide to call it any equation, but I'll prefer to still call it equation 1 because all I have done is just to clear the fraction out. So now you've converted these fractional equation to a linear equation. Now do the same thing to the other equation, which is this one right here. You have it in this form. Then you take the LCM of 4, 3, and 6, which is 12. You multiply all 3 by 12, and if you work that out, you'll be having 3y minus 4x equal to 2. We all know how to get that. So this is now equation 2 because it has now become a linear equation. So we have this our equation, we have this our equation 2. So this is our equation 1, which is right there, and this is our equation 2. So let's see how we solve this using elimination method. Now our equation 1 is this, our equation 2 is this. Now remember I told us that the first thing that should come to your mind is make sure that the variables are aligned under themselves. As you can see this one right here, the variables are not aligned under themselves. So what do? Try to adjust one so that they will be aligned under themselves. So if I pick out this equation 2, this equation 2 could also be written in this form because I will have minus 4x plus 3y equal to 2. I have not changed anything. I believe I've explained this earlier on that this on this side doesn't change. It's just rearranging on this side equals to 2. So therefore I can now write this again as this. This is my equation 1. Then this will now become my equation 2. Now in this case, now I've aligned them being on their cell. Then I can work this out now by asking myself, which one do I want to eliminate? Do I want to eliminate x or eliminate y? So if you want to eliminate x, you make the coefficient the same, and if you want to eliminate y, you make the coefficient the same. So which one are we eliminating? I think we're eliminating y this time around. Yeah, we're eliminating y this time around, and I think it would be preferable if you eliminate y this time around. Why? Because y will have lesser values when compared to x. Because if you decide to make this by multiplying this with 4, by multiplying this with 3, it will give you 12. But if you work with this one is giving you 6, which gives you a lesser value. I remember in mathematics, once you work with lesser value, it makes your work pretty easy. Well, it depends on you, it depends on how fast you are with it. So we've decided to eliminate y now, and by eliminating y, that means we ask ourselves, how can we make the coefficient the same? We can make the coefficient the same by multiplying equation 1 by 3, by this 3, the coefficient of this one here, and also by multiplying equation 2 by this 2, the coefficients here. Like using the top to multiply the bottom and using the bottom to multiply the top. So if we multiply equation 1 by 3, we're going to be having this, that is 3 times 3x is 9x, 3 times 2y is 6x, 3 times 24 is 72. And also using 2 to multiply equation 2, which is right here, 2 times minus 4x is minus 8x, 2 times 3y is 6x, and 2 times 2 is 4. So this is what we now have. The next thing, because they have now been made the same coefficient, what do? We draw a line under. So by drawing a line under, you now ask yourself, if I decide to add them, because it is this value that will determine which sign you introduce. If you decide to add them straight up, 6y plus 6y is going to be 12y. In that case, it's not eliminated anything. It's not eliminated at all. So what you do is you introduce a negative sign. Why? Because when you introduce a negative sign, minus times plus is going to be minus. Then you have 6y minus 6y, which eliminates that straight up. So now I know that 6y minus 6y, because minus times plus is going to be minus, so you're having minus 6y. So 6y minus 6y cancels out. Then what you're having here is this. Remember that this negative sign you introduce must multiply each of the term. Must multiply each of the term. So I will use this to multiply this term by there, cancelling this out. So now we use it to multiply this term. Minus times minus, that's going to be plus. So in your mind now, you should know that this is plus 8x cease to become minus 8x. So you now have 9x plus 8x. I'm sure you know that answer. That's going to be 17x plus, of course, this has been eliminated. So what we have is 0. And you may decide to put the 0 or not. It doesn't really matter. Now, the negative here multiplies the number here. That's going to be minus 4. So what you're having is 72 minus 4. 72 minus 4 is going to be 68. So what we're having is 17x plus 0. That's going to be 17 equal to 68. If we make x the subject formula, we all know how to do that, and x is going to be equal to 4. So now that we know that x is 4, what do? We substitute 4 for x in equation 2. You could decide to use equation 1, but remember this 24 is having a larger number, so it's better you slot it in right here. Well, it's just intuitively, anyhow you like, you can slot it in any value. Most important is for you to get the answer. So if we use equation 1, anywhere I see x, I will slot in 4. So instead of writing 4 here, instead of writing x here rather, I'll write 4. Then I'll be having 3y minus 4 times 4, that is 16 equal to 2. I'll try and make this y the subject formula by first moving this one over to this side. So I have 3y equal to 2 plus 16. Then 3y is going to be equal to 18. So by dividing both sides by what? By 3, I know that yes, y will now be equal to 18 divided by 3, that is 6. So now I know that x is equal to 4 and y is equal to 6. As simple as that. Now let's check this question out. We are told to find x and y if 3 to the power of 2 minus 2x minus y is equal to 1 and 16 to the power of x divided by 4 is equal to 8 to the power of 3x minus y. Now this is like indicial equation, simultaneous indicial equation. So how do we do it? The first thing is always to try and take it to a linear equation. Just the same thing we did for the fractional part. Clear out the fraction and take it to a linear equation. This same thing goes for indicial equation. Clear the indices out so that we have the linear equation. So this is the first equation that we have. What do? How do we clear this base out? Now remember this one here. You know that this one is still the same thing as 3 raised to the power of 0. Now we are using 3 raised to the power of 0. We could have decided to use 4 raised to the power of 0, but if we use 4 raised to the power of 0, in that case it won't align with this base and I won't be able to eliminate anything. But since I know that the base over here is 3, I know that yes, once I introduce something of having a base of 3, I'll be able to eliminate this base out. So what happens is that I introduce 2 raised to the power of 0 because I know that this 2 raised to the power of 0 is still the same thing as well, 1. Then in this case, they're having the same base, so they cancels out. Then what happens? The power will be equal. So I will have 2x minus y, which will be equal to 0, and that becomes my equation 1. Now, if I deal with the second equation, which is right here, all I have to do is to work it out in a way so that I'll be able to have a linear equation. And how do I do that? Remember that this 16 is still the same thing as 2 raised to the power of 4, and the 4 there will multiply the power here, which will be 4x over this 4 is still the same thing as 2 raised to the power 2 equal to. Now 8 is still the same thing as 2 raised to the power 3, and remember the power will multiply the power already outside. So because these are two terms, you have to open up a bracket. You have to be very careful here because the power will multiply each term. So what happens if I apply change this dividing line to a division sign? We're going to be having this right here, and if we multiply this one out here, if you expand it, you're going to be having what is right here. So what we do now is we apply the rule of indices here, pick one and subtract the power, which we're going to be having this, and this is this. Now they're having the same base. So what happens? The base cancels out, and once the base cancels out, then the power will be equal. So now the power is now being equal to this. So what do? We collect like terms to be able to simplify it further. Collection of like terms, we're going to be having this. I have minus my 3y here. If I take this minus 2 over to this side, it becomes plus. If I take this my 9x to this side, it becomes minus. So for minus this, that's going to be minus 5x equal to minus this plus this. So therefore now, if I now take this my minus 3y back inside, it becomes plus 3y equal to 2. Now this becomes my equation 2. So I have my equation 1 and my equation 2 right there. So this is my equation 1, this is my equation 2. And we see that they are aligned, they are under themselves. So the next question you're going to ask yourself, which one do I want to eliminate? Do I want to eliminate x, or do I want to eliminate y? Now, here I think it would be better if we eliminate y. Why? Because in this case, you don't have to be because if you decide to eliminate x, you are going um a 3 times step ahead of what you should have done by eliminating y. Why? Because if you eliminate x, the only way you can eliminate x is by making the coefficient the same, and the only way you can make that the same is when you use 2 to multiply 5 and when you use 5 to multiply 2. But if you look at y, you don't even have to multiply, you don't even have to use 1 to multiply this one, because one multiplying everything will still give you the same thing. All you just have to do is to use 3 to multiply equation 1, because once you use 3 to multiply equation 1, the coefficient of y is going to be the same. What I'm trying to say is this: if you now use equation 1, you multiply with 3, you have 6x minus 2y equals to 0. You don't need to disturb yourself by multiplying equation 2 with 1 again. It still gives you the same thing. So you're going to be having this right there. So instead of you saying, oh, by eliminating x, you use 2 to multiply 5 and you use 5 to multiply this, which will give you larger values, and you are doing a step ahead. You just multiply equation 1 by 3 again. Remember, why we always multiply the top by the bottom and the bottom by the top is to make them the same. So if you can figure out a way whereby you can just multiply one of the equations straight up, so that the coefficient of the variable will be the same, just do that straight up instead of using the bottom to multiply them and the top to multiply the bottom. The main essence of doing that is just to make the coefficient the same. Now here we've made the coefficient in value the same, though the coefficient are not actually the same, as this is minus 3 and this is plus 3, but in value they are the same, and that is what we're after. So what's the next thing? You what? Introduce the line. And you now ask yourself, am I supposed to add or plus now? Because sorry, am I supposed to add or subtract? Because we've been introducing negative sign all the while. Now you ask yourself, this minus 3y plus 3y, minus 3y plus 3y is going to be what? 0. So because minus 3y plus 3y is going to be 0, there is no need for you introducing negative sign. The main essence of introducing negative sign all along, we all know, is to be able to cut it out. Assuming maybe we have plus 3y here, and we now have plus 3y plus 3y. In that case, plus 3y plus 3y would have been 6y. There's no way to eliminate it. So the only way to eliminate it is to introduce the negative sign. But here we have minus 3y plus 3y. The way it has already been eliminated, because minus 3y plus 3y is 0. So there's no need for introducing a negative sign. We'll just add everything straight up. So minus 3y plus 3y cancels out. Then the next thing is 6x minus 5x. Of course, that is going to be x. Then 0 plus 2, that's going to be 2. So we are saying that x is 2. Straight, as easy as that. Then the next is to substitute for x in equation 1. I believe you want to pick equation 1. Now 3x minus y will be equal to 0. So anyway I see x, I slot in 2, which is going to be 2 here. Then I have 4 minus y equal to 0. So what do I have? Minus y. When I take this to the other side, it becomes the minus y is going to be, remember, 0 minus any number becomes the negative of that number. So what do I do now? Remember that I'm having the coefficient here as minus 1. So I divide both sides by minus 1. Then negative cancel out negative on this side. Then y is going to be equal to negative cancel out negative. 4 divided by 1 is 4. So now I know that x is equal to 2 and y is equal to 4.